This lesson is factoring by factoring out the greatest common factor and factoring trinomials of the form x squared plus bx plus c. When you're factoring out the greatest common factor, you can list all the factors of the numbers and find the greatest one, or write the prime factorization and then multiply all the common prime factors. Factoring the greatest common factor from a polynomial is you're going to take out the variables with the smallest exponent value. So let's get started. Okay, between 40 and 60. Well, we can list the factors of 40 and the factors of 60 and find the greatest one. Or we can do the prime factorization of 40, that's 2 times 20. 2 times 10 times 5. So the prime factorization of 40 is 2 times 2 times 2 times 5. And the prime factorization of 60, we can do the same thing. 3 times 20, 2 times 10, 2 times 5. So it's 2 times 2 times 3 times 5. And we're going to circle the common factors, prime factors, a 2 here, a 2 here. We write it down once. 2 here, 2 here. We write it down again. 5, 5. We write it down, multiply them all together, and you get the greatest common factor is equal to 20. Now let's try this next one. Well, we need the greatest common factor between 12 and 20. And since the numbers are pretty small, we know that it is 4. And if we look at the x's, the smaller exponent would be x squared. We're going to write that down. And the smallest exponent on the y is just y, or y to the first. So that's the greatest common factor. Now let's do some factoring problems. This one is to factor out a -1 from each of these. So I'm going to put a -1 in front of the x. So I'm going to pull it out in front. If I do that, -1 times x is a -1x. And -1 times a +9 gives you -9. See, when you redistribute, we get back to where we started, which is the beauty of factoring, is you can check your work and see how great you're doing. When I think of the upshot of the deal is if I'm pulling a -1 out, everything inside the parentheses will then change their signs. So if you think about this guy, I'm going to pull a -1 out. It'll be -5 plus y. But you know what? I don't really love the look of that. You know, there's some math expressions that don't have the look going on. So I'm going to write the positive y first, take away 5. It's equivalent. Both of those are exactly the same thing, but this is just more sophisticated. And you write a little guy with a bow tie because that indicates sophistication. Next. All right, now we're going to just factor out the greatest common factor from each polynomial. Well, if we look at A, we realize that 8 is a common factor between 8x and 16, and there's no other variables in the problem, so I can't pull any of those out. So I'm left with x plus 8 times 2 is 16. And again, even if I just check my work by inspection, I know 8 times x is 8x, 8 times 2 is 16, bada bing. Now look at this next one. It has a whole bunch of x's and y's, but the coefficient, there's only one coefficient of 2, the rest are 1s or -1s. So I really can't pull anything out that's going to do any good. I could pull out a 1, but that really doesn't do me any good. Now let's move on to the x's. Remember, you can only pull out what the people with the least have. So this guy can give up 4 x's, this guy can give up 3, but these two can only give up 2, so I'm just going to pull 2 of them out. And similarly with the y's, you think about how much can each person basically give. And this guy only has one y going on, so I'm pulling him out. So for this guy, I pulled out 2, so I'll have 2 left over and 4 left over with the y's. 1 x left over and 2 y's left over. Here I'm just left with a y, and the last one I'm left with a -2. And again, if I redistribute, I can see that what I did was correct. Now let's do another one. Yeah, let's. And we're going to pull a common factor 9 out, because 9 goes into 9 and 27. And we're also, this guy can only cough up 2 y's, so y to the second. So now I'm going to go and figure out what's left. Well, I pulled the 9 out. I have 4 y's, y to the 4th, because y squared times y to the 4th is y to the 6th. And I have 3, because 9 times -3 is a -27, y squared, plus, well, I pulled out the entire thing, but I need a placeholder, because if I don't put anything there, when I go to redistribute, I'm not going to get a trinomial. I'm going to just get a binomial. Next. All right, this next piece is called factoring by grouping. So if you look at this, let's do factoring by grouping in blue. So if you look at this, okay, I have an x here, an x over here, an x here, but there's no x here with the -4, so I can't pull that out. Oh, I got a common factor of 2, 2, and 2 in the first 3 terms, boop, 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 but no common factor of 2 here. So I have no common factor among all the terms, so I'm going to try factoring by grouping. And here's the deal. You break it down, you have it here, and here, and you're going to pretend that 8x minus 4 is your problem. So I'm going to pull out a 4, and I'm left with 2x, take away 1. Perfect. Now I'm going to factor this second Gubahava. I'm just going to pull out an x, because I don't see anything else that can pull out, and I get 2x, take away 1. Ooh, now I'm psyched, because this 2x take away 1 and 2x take away 1 are common. So I'm going to pull that one out in front. And what do I have left? Well, he's gone. So I have 4 left, and he's gone because he's in front. See, because then if I redistribute, you guys, I'll get back to here. Good? So the final answer is 2x minus 1 times 4 plus x. And you can write this a multitude of ways that are equivalent. You could write it as 2x minus 1 times x plus 4, x plus 4 times 2x minus 1, bunch of different ways. Okay, that's my little or. Okay, next, let's try another grouping problem. Yeah, let's. So here we go. This first guy and this second guy. Now, how do I know to group? Well, sometimes the directions tell you to group, but you know to group when all of the terms, you can't find a common factor among them. All right, so this first one, I'm going to pull out a 5 and an x, and I'm going to be left with an x minus 2y. Now this guy right here is a little bit tricky. Whenever you have a minus in front, you're going to factor out that -1. So -7, because 7 can go into both. So I'm left with x, but not plus 14, not plus 2. You need that y in there. It's going to be a -2y. And the dead giveaway, you guys, is if this factor's right here and this factor's right here, if all is right with the world, these two things should be the same. So if you screwed up a sign, you're like, oh, I might have done something wrong. So now I'm going to pull out that common factor of x minus 2y. And I'm left with 5x minus 7. And there's my final answer. Now we're going to factor trinomials of the form x squared plus bx plus c. Now earlier in this module, we multiplied two binomials together using the FOIL method, and now we're going to unfoil, okay? And we want to get it of the form this plus this. So we're going to factor by trial and error, and any trinomial that cannot be factored, we're going to write its prime. So let's take a look at this first one. This one's a beautiful one because I have two positives. So I claim we can break this up into two binomials. Well, the first piece is wicked yay because it's x squared, so I can break her down into x times x. And since I have two pluses, I can everything's going to be positive. And now I'm going to look at this guy here and I'm going to say, okay, give me the factors of 24 that add up to 10. And you're like, why? That is 4 times 6. Very good, because it adds up to 10. Now let's check our work. This should be it. I should be like, yeah. Okay, so we're going to FOIL it back out, and I'll do that in red so you know that's not part of the answer. X times x is x squared. X times 6 is 6x. In will be 4x. Last will be 24. And bada zinga, we go back to that piece. Okay, now let's do the next one. This one's a little bit more challenging because there's a negative 11 here, but also positive 24. So let's take a look at this. Okay, if I have a positive at the end here, both of my signs in my binomial will be the same. And what signs will they be? This one will be negative. This one was positive. So if this second sign is positive, both of the signs in the binomial will be the same, and in this case they'll both be negative, this determining sign. So I'm going to write two negatives. X squared, I'm just going to put an x times an x will give me x squared. And then I need to get the factors of 24 that add up to negative 11. And you're like, what? What? So 24, negative 8 plus a negative 3 will add up to negative 11, which is inside. But I already have my little cute negative signs there, so I can just pop in an 8 and a 3. Now, here's the deal. Let's check our work. X times x is x squared. X times negative 3 is a negative 3x. Negative 8x in the inside, and positive 24. Bada bing. X squared take away 11x plus 24. But what is my answer? My fully factored form, do you like that? Fully factored form is x minus 8 times x minus 3. Now let's look at some problems that just are a teensy bit more intense. Again, I still only have a y squared in front, so when I do this, I will get y times y. Now I have a negative in the back of the bus, so my signs in my factors will be opposites. One will be positive, one will be negative. And what I do need is I need the factors of negative 40 that add up to negative 3. So if I think about it, well, how about 8 and 5? Let's do a negative 8 plus a regular 5. Well, that gives me negative 3, so I'm psyched. So I know that the negative guy has to be an 8, and the positive guy has to be a 5, and I'm good. Let's double check. Now, instead of checking the first and the last, I'm going to do something that I call a little cradle. I think that looks like a cradle. Inside is a positive 5y. Outside is a negative 8y. So if I check that little cradle thing, I'll get a negative 3y, and I've checked. So I'm good. And then you can spot check the other ones. Y times y is y squared. Positive 5 times a negative 8 is a negative 40. Let's do the next one. Yeah, let's. All right, so here we go. We're going to get x times x is x squared. Again, this is a negative 5, which you're like, oh, I know, then the signs have to be different. And we have to figure out, I need the factors of negative 5 that add up to a positive 4. Well, if you think about it, positive 5 and a negative 1 are the ones that are going to do it. So I need a positive 5, negative 1, and I'm good. I can do my little happy cradle. This is 5x. Outside negative 1x. Ooh, 4x. Checkerino. Good. Final answer, this guy. All right, not your check. Now here's tips for factoring trinomials. Arrange the trinomial in descending degree order, meaning let's put the exponents in from highest to lowest on the variables. Factor out any common factors first, and then this is my sign guy. If the second sign is positive, the signs of the two factors will be the same, and they'll both be the first sign in the trinomial. If the second sign is negative, then the signs of the two factors will be different. If the leading coefficient is 1, the factors of the last number must add or subtract to the middle number, which we've been doing. Okay, here we go. First, we are going to look and see if there's a common factor, and of course there is. It's 3. This is a two-step problem. Okay, you know the dance step, that's the two-step. Well, this is the factoring problem, that's the two-step. So don't be lazy, don't try to factor it all at once. So we're going to write down the leftovers. X squared plus x minus 3 times what gives me a negative 60? Negative 20. And now we are going to bring down that 3, and then we're going to factor the remaining trinomial. Well, I know x and x. Ooh, I see this second sign. That means the signs are opposite. Don't forget that this is really a 1x, so I need the factors of negative 20 that add to positive 1. So I'm thinking 4 and 5, right? 5 plus a negative 4. So I need a 5 here, negative 4 here, and I'm golden. If I don't put the 3 in front, I have not completely factored it. So how would you check your work on this? Well, you would multiply these two binomials first to get this guy right here, and then pull the 3 through. 3 more. So now the first thing we're going to do on this first one, notice that it's not in descending degree order, so we're going to write it that way. 2x cubed plus 20x squared plus 50x. Perfect. Now I notice, aha, there's a common factor of 2 and another common factor of x, and that's all I can pull out. And again, this is the two-step problem. So I have x squared left over here, 10x, and 25. Good. And now, this one's beautiful because everything's nice and positive. So my signs will be the same, and they'll both be positive. I have an x and an x. Now the only factors of 25 that add to factors of 25 that add to 10. Well, that's 5 and 5. Okay, beautiful. Now you can actually write your answer to this as 2x times x plus 5 quantity squared if you want to. That's, again, here's my symbol, sophisticated. Cool. So let me get this a little bit clearer here. So factors of 25 that add to 10. There we go. And then this would be my final answer, but you can write either one. Next, I'm psyched because this guy is already in descending degree order. I'm going to factor out the common factor of 2. There's nothing else in common. I'm left with x squared, take away 12x, take away 35. So I need the factors. Well, before I get into that, I say to myself, self, since this last sign is negative, I'm going to have opposite signs in my problem. X times x is x squared, so I need the factors of 35 that, actually negative 35, that add up to negative 12. Okay. How about negative 7 and negative 5? Well, sure, that adds up to negative 12, but it does not multiply together to get a negative 35, does it? So we can't use these. And then I'm thinking, well, 35 and 1 isn't going to add up to a negative 12. So this is what we do. We cross this off, and we stop here, because this remaining trinomial is prime. So we actually say that this trinomial, this is a side note. It's my little notes. A side note, the trinomial x squared, take away 12x, take away 35, is prime. I can't break it down anymore. Okay? Now let's look at the next one here. Yay, I can factor out a 3. I can factor out an x. And again, this is the 2-step, you guys, so you've got to write down what's left. Don't try to factor it all at once. Nice. Now we need the factors of negative 12 that add up to a negative 4. All right, let's not get ahead of myself. I need x and x. I know the signs are different. Good. And I'm going to say, okay, let's do negative 6 and a positive 2. That'll give me negative 4. Cool, and there's my answer. Notice how I brought down the 3x? Everything's hunky-dory. Now, with patience and perseverance, you can do this lesson. Just check with your teachers if you have questions, and please don't get frustrated, because it takes a lot of practice to factor well. Good luck.